Hi, everyone. So let me get started. It's a pretty interesting title. So, manufacturing financial data to power AI. Yeah. So, as Mui was saying, I'll be focused on basically describing what do we do at S&P when it comes to fixed income, mainly fixed income pricing data. Basically, what do we do? How we collect the data. We get it from market participants, from industry. How we clean the data, collect it, process it, and basically distribute to clients. That's our fixed income pricing. Then also we'll talk about our parsing service, which is basically one of the main fuel sources for the data. I'll spend some time on CDS pricing, which is one of our more interesting data sets. And if we have time, we'll talk about the derived data sets. So overall, we actually came from the IHS Markit merger with S&P. And so we now sit within market intelligence. It's called data valuations analytics. That's basically our group. And then I'll be talking about data. And as part of data, we have fixed income pricing. So before that, how many people know what's like fixed income, or what is a CDS, or what is a bond? People know what's a bond? Yeah, CDS. So CDS is credit default swaps. So basically, credit default swaps, that's your kind of security or protection against credit risk or protection against credit default. And so in our pricing service, we essentially price all of these different instruments using market data. So we're getting data from many different contributors from all the major market makers. So let's say JP Morgan, Goldman Sachs, Morgan Stanley, they all contributing data to us by collecting data from the industry. We're aggregating the data, and then we price all of these different instruments. For the most part, the pricing process itself is automated. But we also have an analyst team that reviews the data and kind of makes sure everything is fine. In terms of coverage, it's driven by clients, and it's driven by liquidity in the market. I think it's interesting. I'll be talking more about the pricing engine itself and how we do the pricing. It's mostly automated. It depends on liquidity of the different instruments. So if it's a liquid instrument, we're typically getting a lot of data, and we'll tend to use what we call a composite pricing, where we basically, like, at the end of the day, average the contributed data. If it's less liquid, we may be using some evaluated pricing approach. In terms of sources of data, so parsing, essentially, that's our main fuel source, where we get Bloomberg runs, from the sell side, traders sending data to their clients, to the market. We get all that data ourselves. We parse all that data, basically extract the data, and we can use that in our pricing process. We're also getting direct feeds from the banks. But we're using trades for bonds, things like that. So that's all field data for the pricing. Depending on the liquidity and frequency of the data which we're getting, we're able to produce kind of for different asset classes. We have different frequency of data ourselves. So we can have live pricing for something liquid like bonds or CDS, or for muni bonds, which are less liquid. We produce like several snaps a day. In addition to the automated system that's doing the pricing, we also have the analyst team that does the quality checks and ensures it's all accurate, essentially. And we're looking at price movements, we're looking at coverage, we're looking at any sort of news or additional market color. So we're able to check the pricing and adjust the pricing if necessary. So maybe I'll get into a little bit more on the parsing, which is essentially the service that, it's a client-facing service, but we're also using that data in pricing itself. So we're getting millions of messages daily. They're sent essentially from the sell-side banks. They're sending Bloomberg runs to the buy side. The buy side forward those to us. We have contractual agreements with both the buy side and the sell side. And to to allow us to use this data. And essentially, we use machine learning and NLP to, first of all, as we have many different asset classes, we have to figure out, as you're getting a message which looks like this, which is pretty hard to read even for a human, frankly, if you notice. So it's a bond message, right? It says essentially with bonds you have ticker coupon maturity as the identifier, and then there's pricing information. So the parser has to figure out which instrument it is. So extract that data, map it to an ISIN for the bond, do some pricing enrichment conversions, and then that's the parsed data. The way it's set up with clients is that each client gets their own dedicated setup or their own environment. They're sending, and they can only see their own data. So they're sending us their data, and they're basically getting back their own data in a structured way. So extracted from this sort of raw message format to an actual feed, and you can basically parse millions of messages this way. So it's quite useful for clients, but we're using this data ourselves to power our pricing services. And then talk about CDS pricing as an example for one of our pricing services. So overall in CDS, for those of you who you may or may not know, originally started from market. So it was market before. For those of you who are in the CDS or familiar with CDS, it was market, then IHS market. Now we're part of S&P. So essentially, it's a leading provider of pricing and transparency metrics and information for the industry. We're pricing all different asset classes, including credit default swap, like single names, individual companies, CDS, or indices, options, things like that. In addition to pricing, we also have reference data, indices, and some models as well. So that's just basically our price viewer, where you can see the prices, you can see the curves. The way the methodology works, which I think is maybe interesting to cover, is that essentially, as I mentioned, we're getting 20 plus market makers submitting data to us. We have an automated pricing system which collects all that data and has to decide which data points to use, which ones are better, which ones are can be rejected. At the end of the day, we're checking for different attributes like staleness, outliers, activity. So we can check, okay, this dealer, let's say JP Morgan, is actively quoting this name or this given issuer, so we can we'll take their data. Or if somebody is not as actively quoting, we're not going to be using their data. So at the end of the day, for each individual issuer or index instrument, basically, whenever we're pricing it, we have to select the best contributors or the most active dealers in the market and essentially average their prices to come up with a market price. It's an interesting example here, maybe hard to see, but essentially that's how it looks like internally. So we have a lot of different contributors, and we have to decide which ones to take. And there's a data quality score. Sorry, it's a bit hard to see. Basically, there's data quality score calculated based on different metrics like staleness, outliers, activity, and we're picking basically the top ones to be used as the price, and then just the highlighted one is an outlier, which was removed. The pricing itself is continuous, so as we're getting data throughout the day, it's an automated process which runs everything, and then we have live pricing, and also we have snaps, and then the end of day snap. And I'm using CDS as an example, but essentially it's similar for bonds or for loans, for anything that we price. It's a similar process where we're collecting the data, aggregating this, essentially averaging, and then publishing this to clients. It's important to know that there is an analyst team, like a global pricing team, that sits on top of this and checks to make sure that all the data is valid, or most of it is valid. Overall, in terms of use cases for the data, clients use it obviously to mark their books, for pricing, price discovery, valuations, risk. But for this conference, there's also data science use case for the fixed income data. So data science use cases will be essentially building models based on the data, looking at relationships between different asset classes like CDS, loans, equities, like looking for signals, because for example, people can use CDS to trade equity. So it can be a signal. And let's say if CDS moves or an index moves, maybe it's an early warning for for the equity movement. So for example, like if you're familiar with CDS, there's a CDX North American Index, which is similar in a way to, let's say, S&P 500, but it starts to trade earlier in the day than S&P 500, like than the equity market. So you can basically see, okay, if CDX moves one way, it means that equity will tend to move in the similar, like it's in the opposite direction, but it's a no relationship. So basically, when credit spreads go up, equity prices go down, and vice versa. So you can basically use different asset classes. You can find relationships between them and find strategies to trade different asset classes. If there's lead-lag relationships, for example. So we will spend time on all these things like coverage history, but we also, I think, linking is important between data sets, knowing like that it is one company, because like one company can have equity, CDS, bonds, loans. It's all different IDs. So you need to be able to link this together. So this was basically kind of the main part of it without pricing data sets. And I also wanted to talk a little bit about derived data sets, what we do with them. I think wanted to start with, let's say for bonds, we have issuer curves. So before I was basically covering individual bond pricing. And once you have individual bonds, you can create issuer curves where you can see, the whole curve for the issuers. You can see potentially where they will be issuing new bonds. And we have been using some data science techniques here, basically, to check for the data quality. And effectively, what it does is we select the most liquid recently issued bonds, draw a curve, and that becomes the issuer curve. But there's a whole methodology around selecting the bonds, removing the outliers, ensuring the movements are consistent day over day, things like that. Another example would be of like kind of more advanced modeling that we do for less liquid. Actually, let me do this one. For less liquid instruments is, let's say, evaluated pricing. So for liquid ones where we have a lot of data, we use composite pricing. For liquid ones, we can use evaluated pricing where, we are deriving something which is not observed. So in this case, for evaluated CDS, we take bonds, we do a bond implied curve, we add the CDS bond basis to it, and basically becomes an evaluated CDS service that we have. So it expands coverage beyond the observable one. Can still be used in risk, for example, or other use cases. Another one I wanted to cover, I guess, is sector curves. So I think it's also relevant for, let's say, if you have less liquid, instruments, they can be priced or they can be somehow managed using sector curves. So a sector curve would be like for, let's say, for bonds for a given sector, like financial, single A, North America. So what does the curve look like? And we have those for bonds, for loans, for CDS. And you can use those for risk, sometimes for valuations, for things like that. I think that's probably pretty much it for me today. Any questions? Hope that was interesting. Yes. Sure.
How many people manage all this data?
How many people manage all this data? It's a good question. Hundreds of people. Hundreds. Maybe like 500 people.
How many?
500. But that's including, operations, development, testing, because it's a lot of data sets. Is that
I'm impressed.
does that make sense? No, I mean it can be even more. So it depends. It's for us. It's a pretty big business, I would say, because it's like all fixed income pricing. Because you're pricing millions of instruments overall, if you count like munis and other things.
I have a question. What kind of look back period of data do you look at for your model training? I imagine pricing is more recent. I don't know if there's any impact from pandemic or pandemic issue bonds, if those are having trouble pricing your algorithms.
That's a good question. So yeah, we do get it from clients. So essentially, the pandemic was stressful because there was a lot of volatility. So in terms of our data, it goes back to like early 2000s across data sets. Obviously, the financial crisis, 2008, 2009, was volatile period, and then the pandemic was volatile. So we have to adjust some of our pricing process and some of our tolerances and checks that we do. So you basically have some of them are dynamic, some of them are configured. So we have to adjust. Yeah, that's why you have the analyst team, so they can basically relax tolerances if needed. But I would say it still was not, that difficult, because if you have data, even if it's volatile, if you have data, you still should be fine in terms of like accurately pricing it.
Okay. You need the microphone.
Oh, okay.
Thanks. For the liquid instruments, for the evaluated pricing, how do you backtest, given that there may not be that many observations to test the model?
Yeah, that's also a good question. So, with the way we do it, so you can backtest it using, composite data. So let's say for evaluated CDS, let's say you have banks, right? So let's you have U.S. banks, right? So let's say, liquid issuers like Goldman Sachs, J.P. Morgan. So you can look at their bonds. You can look at bond implied curve we're getting, and compare it to our composite curve, for example, right? So we can compare composite pricing for the liquid ones with the evaluated pricing, see how that performs. That's one way. We also have, we get feedback from clients. We also have, for some of these asset classes, we have a team that's doing sort of a bottom-up approach, like private vals. So they're basically looking at actual like financial statements and company information to come up with a price. So we can sometimes compare our kind of model pricing with analyst-driven pricing. So this can also be an input. Yeah, but it's kind of an art and a science, both.
Hi, I'm curious if in the process of doing these calibrations, if you produce signals which could be used for alpha, like from the residuals and things like that.
I'm sorry, can you say it again?
If you produce something that like shows a mispricing or shows an opportunity for traders of the bonds to buy and sell, can produce alpha in essence.
Well, since it's a pricing process, right? If you think about it, you cannot trade on this data. So when you're actually trying to trade, you're trading with the dealer, right? So they will give you a price that's what they think is right. We are basically just giving you a price that you can use to mark your books, or you can use for price discovery, for example.
Okay.
But you cannot trade on those prices because you're not trading with us.
No, I didn't mean that. I just meant that it could be used as a signal for a quantitative
signal. Oh, yeah, sure. Yes. But as a signal, it can be used. Well, but it's not guaranteed in a way.
Of course, it's not guaranteed, but there's always seems to be a give and play between risk models and alpha generating models, because you develop a theoretical model, and if that model shows outliers based on things, sometimes it indicates an actual signal I used to do this with equities, but not in the. I was wondering if a similar thing could happen in the bond market.
So people look at relationships between equities, bonds, CDS, credit default swaps, loans, and they try to find alpha. Yeah, using our data sets, they try to link those and then see, okay, one moves, the other one doesn't move, things like that. So they try to find alpha. Yeah, doesn't seem to be too easy, to be honest.
No, it's not. I
not easy.
tried doing that myself.
And because I think when you see alpha, it sometimes has to do with just bid ask and liquidity. So when you actually go and try to trade it, there might be no alpha. So because there's always bid ask apply when you try to trade, and there's liquidity issues and things like that.
Okay, thank you.
Sure. I think just a quick point there. So like equities, you can obviously trade in and out. Like equities, you can trade in and out. You can buy and sell all day. CDS is much harder to trade in and out. Even bonds, you have to it's a process you have to go through. So, yeah.
Your question here. Can you describe your data quality check process, especially whether it's a manual process, fully automated, or black box or rule-based? So just give us some idea.
So some of it is definitely not black box. So that's a good question. So we don't like black box, and our clients don't like black box approach. So we're very transparent in our methodology. We have detailed methodology docs. We'll send you exactly, pretty much exactly how things work. We can answer any questions on that to clients. It's mostly rules based. But it's fairly, things are fairly straightforward. Okay, so let's say for a given instrument you're looking at, so you're getting prices daily, and you, let's say like in this case we had, right? So you're getting prices daily, and then you look at when is this dealer updating? Like, what is the staleness? Did they update today, or is it a price from like 10 days ago? Then you're comparing the different prices, saying, okay, are they? If you see here, they're all pretty much in line except for one, so that's an outlier, right? So we'll look at outliers, staleness, and activity in the market. So they're pretty, I would say, not very difficult rules. So it's mostly rules based, and then the analyst team sort of reviews on top of that. Mostly based on exceptions, like, oh, there's a big tolerance movement, like there's a big change, things like that. So it's a combination of rules-based, analyst review. We do some kind of additional like machine learning-based type of checks as well, but just more like quality checks on the data.
My question is about the data as well.
Yeah.
So you said you have about over 20 contributors and the Bloomberg data.
But that's for one asset class, yeah, for CDS, yeah.
Okay, so is it all structured, or you tell the contributors the format they need to send you the data in, or how do you parse the data? It was like that portion. How do you digest all of the different types of data?
Right. So that's kind of part of the art and science. So we're getting data from different field sources, and I think I had that earlier. So, I mean, parsing is one where you're basically getting the messages, the Bloomberg messages, and you have that's unstructured. So we have to structure that data. But then we're also getting a lot of bank feeds, which are structured. So we give them the format. It's basically XML. So they say, okay, this is it will submit instrument identifier, the pricing. So they upload throughout the day. So that's structured. So it's both. You have to basically get data from different sources. We have to normalize it in terms of like converting it to a given pricing unit, right? So let's say in case of bonds, right? Let's say we're doing it in spreads or prices. In case of CDS, you can do it spreads or prices.
Know the format.
Yeah. So we kind of decide in some cases what's our, let's say, primary price type. So let's say IG bonds, we're pricing on spreads, so we're getting spreads. high yield bonds were pricing on price, so we want to get the price. So we're normalizing the data and we're doing the checks and sort of calculation in the main price type. So there's a lot of involved. So there's parsing, there's normalization of the data, there's cleaning of the data, and then aggregating it.
I have a question. Since you mentioned that you are pricing it, and the pricing often involves a stochastic element on it, right? These prices are mostly stochastic prices, and then you're adding a machine learning layer on the top of it. So how accurate are these? And second part of the question is, are there any benchmark that you compare your model against?
I would say, in terms of how we're testing this, again, our main objective is to make sure that our sort of prices that we publish reflect the input that we're getting, right? So we're testing this against the inputs, and it needs to be really within bid ask. And really, our clients can see some of the same data that we see. So they will challenge us if they see any discrepancies or if we're outside of the bid ask. So we want to be within the bid ask of the quoted, let's say. So for bonds, like people are quoting this, you can see it in multiple places. So you want to be within bid ask. So we are doing active testing. Also, where available, we're testing against trades, including bonds, loans, munis. So we produce like trade studies where we show you the difference between our pricing and trades, like on a monthly basis. And it's usually within like fraction of a basis point.